Okay, now I'll give some one small example, sir. Okay, now uh, let us take one example. Okay, I see. I'm asking Lenin. My scholar is there. He is not married. Okay, he is not married. Okay, let us assume that the class is going on. Okay, this like this workshop he is also attending. I'm asking Lenin to walk from the that test class, that is a classroom. There is a one Nagatamman temple is there near Pondicherry University. I'm asking him to walk to that temple and come back. Right. Let us assume that he is taking 30 minutes, sir, half an hour. After 1 hour, again I am asking him to walk, sir. I am asking to walk, sir. How much time he will take? He may take 30 minutes or he may take 29 minutes also. After 1 hour or next day, I am asking to walk. He may take 28 minutes. Sometime he may take 31 minutes or he may take 32 minutes like that. Now, I have asked him to walk 100 times, sir. 100 times. Each time, how much minutes he has taken, I have observed and I have noted down. Now I have 100 observation. I have one column which is having 100 values. All metric value, 30 minutes, 29 minutes. It is a metric. We can find out average. 1 minute and 29 minutes to 30 minutes to and 30 to 31 equal interval. Okay. It is a metric data. So I can find out average. I can find out standard deviation. Now I have mean as 30 out of this 100 observation. When I found out the mean says 30 and the standard deviation is 1. Mean is 30 and standard deviation is 1. Now mean plus 1 standard deviation. Mean, that is a mean value, 30 minutes. 1 standard deviation, 1 minus 1, that is 29. Plus 1, 31. Now, if I take out of this 100 observation, 29 see, 1 observation, 30, 29, 31. Like that I have. I am cutting how many? 29, 30. Find out 68 times he might have taken 29 to 31 minutes. Then, if I take 2 standard deviation, which means 30 plus or minus 2 standard deviation. Okay, which means 28, 29, 30, 31, 32. So, how many observation? It is 95 observation. If I take 27 to 30, it will be 99 times. Okay. So, what is this one? This is okay. So, one gentleman, Sabishu, it is called Sabishu theorem. That theorem says mean, this side 1 standard deviation, this side 1 standard deviation, minus 1 standard deviation, this side 1 plus 1 standard deviation, it gives 68.27 observation. 68% of the data will be there between 1 standard deviation to standard 1 standard deviation this side and this side. Okay, if it take 2 standard deviation this side and that side, it will take 95 observation. If we take 3, it is there. Very good. Now, okay. Now this is the theory which we are using for control chart also. Okay, now you might have studied there are many control charts in quality control. One is a B chart, X bar chart, R chart, B chart, C charts. All charts you might have studied. In all the charts, okay, X bar chart, you will have X bar values. Okay, then you will try to find out the bar of X bar. That is called X double bar. You will get one value. That you put it as here. That is this value 50. That is the central line. Then you are making the, okay, so this one, this is called UCL. What is UCL is U, that is a mean, plus 3 standard deviation upper. Then lower is mean minus 3 standard deviation. Now, if you plot all X bar values, all X values, all values, okay, so all these things will be here. Okay, now if it is within these three, it will be there. Why we are accepting? We are accepting this one if it is within. See, when I ask Lenin to walk, he is not a robot, he is a man. When he is a man, he is bound to take some deviation. That is a normal deviation. Normal man will take this much here, this much here. That normal deviation we are allowing. Up to 3 standard deviation, we are allowing that side and this side. That is a normal. Bound to take. But when I have asked Lenin to walk from Nagataman temple, when he was going one time, what happened? He has seen the Ajina. Ajina is classmate in MCOM. He has seen the Ajina that side. Then what he has seen? He has jumped from this side to that side, jumped the general line. He is a sportsman. He has jumped and come, hey, Ajina, when did he come? How is this going? Hey, we left that, after that, you are not talking to me. Like that he was talking. And after talking, then he has realized, Sir has asked me to work. Let me go. And you be there, 5, 6 o'clock, you be there. And that hotel, I will come, we will there talk. Like that he is telling. And he has come. Now, how much minutes he has taken? He has taken 45 minutes. The deviation. But this deviation is not normal deviation. There is abnormal deviation. This observation we have to reject beyond 3 standard deviation. We have to reject it in a control chart. Why it is? Because there is an assignable cost. For example, the production process, material may be fault, machine may be fault. That person has slept and he has put something, he is putting material, but he is sleeping and not giving the material, machine is stopped. So, more time, more waste. So, there is an assignable cost we have to reject. So, whenever you take 3 standard deviation, 95 observation which will be inside, 1 observation it will be outside. So, that is the abnormal situation for which there is this one, we have to reject. We have to reject. Okay. So, that side. Okay. Now what happens? See, every time we say 95%, which means we are taking 2 standard deviation this side, that side. If it is beyond that side, 5%, we are rejecting that side, both take 5% that side. Okay, so the values are less and greater. So the significant value is less than 0.05. Reject this side. Reject and null. Reject. Okay, so if this 95% we are taking. Okay, so remaining we are rejecting. We are rejecting, which means we are operating at 95% level of confidence. 95 times. If I say that Lenin will take 20 to 32 minutes. That is my statement. Then my statement will be right at 95 times. That is my level of confidence. 5 times he will go that side and this side. That I am rejecting. That I am rejecting. This is the normal distribution. This is the explanation for normal distribution. What is normal? Why we are taking 0.05, which means we are operating at 95% level of confidence, which means we are taking 2 standard deviation this side and that side. Okay. Sometimes you will take 99% also. Then we have to look at the significant value less than 0.01, 99%, then 1%. Okay, anything you can adopt, anything you can adopt, right? So this is normal distribution. This